Hello guys, welcome to my YouTube channel. So here I am gonna give explanation of leg operon. You might be wondering when your lecturer starts showing you expression cassette or gene anatomy, then you see leg operon and you have no idea what is it actually. And your lecturer just give you like a glimpse explanation and you ended up full of question mark. So here I'm gonna give you a brief but clear explanation what is leg operon actually mean. The lack of a nuclear membrane in prokaryotes gives ribosomes direct access to mRNA transcripts, allowing their immediate translation into polypeptides. This makes transcription the rate-limiting step in prokaryotic gene expression and therefore a major point of regulation. The classic example of prokaryotic gene regulation is that of the leg operon. This operon is a genetic unit that produces the enzymes necessary for the digestion of lactose. So this is some gist that I want to emphasize because these are the key components of regulatory as a whole. The repressor protein is produced continuously by the I gene, which is not under regulatory control. The repressor itself is formed from a subunit that self-assemble to form the active tetramer. When present, the inducer allolactose binds to the repressor subunit, preventing their assembly into an active tetramer. Allolactose is produced from lactose by beta-galactosidase at a steady low rate and thus serves as a lactose signal. Another regulatory component is the catabolite activator protein, or CAP. We can call this guy CAP. CAP forms an active complex with intracellular cyclic adenosine monophosphates, or CAMP, which accumulates in the absence of glucose. CAMP is a starvation signal thing. RNA polymerase binds to the leg promoter effectively only when the CAP-CAMP complex is also bound. This ensures that the leg operon will be expressed only when the glucose is absent. The leg operon exhibits both a negative control and positive control. Under negative control, a regulatory factor is needed to prevent expression of the leg operon, whereas under a positive control, a regulatory factor is needed to permit expression of the leg operon. The first one is a negative control. If lactose is absent and glucose is present, the gene products from the leg operon are not needed. Thus, a regulatory factor, the repressor protein, prevents leg operon expression. Since the repressor is produced continuously assembles as its active tetramic form, it is available to bind to the operon and prevent transcription. The second one is positive control, where the condition is with lactose but no glucose. If no glucose is present and lactose is present, the gene products from the leg operon are needed to use the lactose for energy. Thus, a regulatory factor, the CAP-CAMP complex, is needed to permit expression of the operon. Because CAMP is a starvation signal indicating an absence of glucose, it is available to form the CAP-CAMP complex and permit transcription. Next, last but not least, positive control, where the condition is with lactose and glucose. If both lactose and glucose are present, the regulatory mechanisms act to avoid wasteful expression of the leg operon. Even though the repressor is inactivated by the presence of lactose, RNA polymerase cannot bind to the promoter since the CAP-CAMP complex is absent owing to the presence of glucose. So yeah, these are brief explanations of leg operon. I hope you understand. Thank you.